Hey guys, in today's video I'll be showing you how to do the Raphson method, which is a more efficient iterative method for approximating roots to an equation. Okay, so the Raphson method is a more efficient iterative method for approximating roots to an equation. I'll go through how it works in a moment, but the main thing that you need to know for it is this formula right here. xn add 1 is equal to xn minus f of xn over the derivative of xn. So you need to understand how to differentiate in order to do this method. However, that is one of the topics that I'll be covering soon in some upcoming videos, and additionally you should have been doing that in your A-level course anyway. So the Raphson method works by putting in a value for x0, and where that intersects with the line you find the tangent for it, and then where the tangent intersects the x-axis, then that becomes your x1 value, and then you find the tangent to the curve at that point, and then find where that crosses the x-axis, and so on and so forth. And you can see you get an increasingly more accurate answer each time you do it, which is why often in questions you will only be asked to apply the Raphson method once. There are a few things to watch out for though, which I have demonstrated here. The first one is if starting values are not chosen carefully, the method can converge very slowly, and if any value of xn is a turning point, then the method will fail completely because it won't cross the x-axis at any point. So I've got two questions that we're going to go through. So the first one here is f of x is equal to x squared minus 4 over x, add 6x minus 10, where x is not equal to 0. Apply the Raphson method once, using negative 0.4 as the first approximation for alpha. So looking at the formula, what we want to do is find the differentiated version of the function that we've been given. X squared becomes 2x, minus 4 over x is the same as minus 4x to the power of minus 1, so that actually becomes add 4x to the minus 2, but add 6x just becomes add 6, and the minus 10 disappears. At that point we can now build our Raphson formula. So xn add 1 is equal to xn minus f of x on top, x squared minus 4x to the negative 1, add 6x minus 10, all over 2x, add 4x to the minus 2, add 6. And then we can put our value of negative 0.4 into the equation and work out the answer to the question. This gives us an answer of negative 246 over 755. That's equal to negative 0.325827, etc., which is roughly equal to negative 0.326. Okay, so that was our first example, and now I'm going to do the same thing again for this next question. So what we want to do is find the differentiated version of our function. X cubed becomes 3x squared minus 2, and then the 1 disappears. And we're using 1.5 as our first approximation for alpha, applying the Raphson method once to find a second approximation. And now that we have the derivative of the function, we can build our Raphson formula. Xn add 1 is equal to xn minus the original function, x cubed minus 2x minus 1, all over the derivative of that function, 3x squared minus 2. And we're using 1.5 as the first approximation, so we put that into our formula to find the answer to the question. And that gives us an answer of 31 over 19. As a decimal, that's 1.631579, which is roughly equal to 1.63 to 3 significant figures. Now you might be asked questions with more complex functions, perhaps trig functions or functions including e or logarithms, and this method works just the same with those as well. However, for the sake of simplicity, I've chosen these ones for the differentiation. That way it doesn't overwhelm you with complexities. So if you found that video helpful, then leave a like. Comment down below any topics you want me to cover in future. And I'm actually considering doing more videos about EPQs, economics, perhaps history, and general productivity and revision videos. So subscribe to stay tuned for that.